All right, here's your Quiz 11 study guide. All right, problems 1 through 4. Let's just start with number 1, where the question is, what is the number of real solutions? In your notes this week, you wrote down that if the discriminant is greater than 0, there's 2 real solutions. If the discriminant is equal to 0, there is 1 real solution. And if the discriminant is less than 0, then there are no real solutions. So you've got 8x squared plus 9x plus 10 equals 0. We're looking for the value of b squared minus 4ac. That is the discriminant. So here's your a is equal to 8, your b is equal to 9, and your c is equal to 10. So we're going to go 9 squared minus 4 times 8 times 10. So in the calculator, 9x squared minus 4 times 8 times 10 gives us a value of negative 239. Negative 239 is less than 0, so there are no real solutions. The other problems that you see there, you're going to do those the same way. I'm going to skip over to a problem like number 4. When you're doing these, just make sure that your x squared, your x, and your 10 are all on the left-hand side of the equal sign. I'm actually going to do number 3. In number 3, you got 11x squared equals negative 4x minus 1. This negative 4x and this negative 1 have to go to the other side of the equal sign. And you can just move them to the other side of the equal sign if you change their signs. So we're going to rewrite this as 11x squared plus 4x plus 1 equal to 0. And our a is equal to 11, our b is equal to 4, and our c is equal to 1. So b squared minus 4ac, we're going to go b, what's b? We got 4 squared minus 4 times a times c. So that is 16 minus 4 times 11 times 1, negative 28. Again, no real solutions. All right, in problems 2 and 4, you will do the same way. Again, just make sure that everything is on the left-hand side of the equal sign when you label your A, your B, and your C. Then in the short answer, you've got 4 of the quadratic formula problems. Remember the quadratic formula, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's the formula that you're going to use to solve those 4 problems. So I will do if you look down at number 4 under the short answer, actually that's the problem that I am going to do. You can do 1, 2, and 3 on your own because they already have everything to the left of the equal sign. So you can label your A, B, and C. But in number 4, you've got a negative 4x squared plus an x equal to a negative 4. All right, you got to add 4 to each side right here. need everything on the left-hand side of the equal sign. So negative 4x squared plus x plus 4 is equal to 0. And now our a is equal to negative 4, b is equal to 1, and c is equal to 4. So we're going to substitute into this quadratic formula to solve for x. Negative 1 plus or minus square root b squared. So we got 1 squared minus 4 times a, which is negative 4, times c, which is 4. A lot of 4s. All divided by 2 times a, which is negative 4. So 1 squared minus 4 times 4 negative times 4 is 65 under the radical, all over negative 8. Now, on this multiple choice quiz tomorrow, you may see an answer that looks just like that. All right? Now, if you need the decimal version of this, you're going to take negative 1 plus square root of 65 and divide it by negative 8. You're going to take negative 1 minus square root of 65 and divide it by negative 8. So, let's see. 1 negative plus 65 square root equals divided by 8 negative. And we get negative 0.88. And then 1 negative minus 65 square root, hit the equal sign, and divide it by 8 negative. And we get 1.13. So those are your two solutions. Negative 88 and 1.13. 5, 6, 7, 8, and 9, you are simplifying the number using imaginary unit. So for number 5, we got the square root of negative 4. Square root of negative 4 is going to be equal to the square root of negative 1 times the square root of 4. Remember that the square root of negative 1 is equal to I, and the square root of 4 is equal to 2. So now we finish this up, 2i. Number 6, square root of negative 9. These are all perfect squares basically. So we got square root of negative 1 times square root of 9. That's equal to I times 3. And we finish that up, 3i. Both number 7 and number 8 are perfect squares, and you will do those the same way. So I'm going to move over to number 9, which is the square root of negative 45. The square root of negative 45, that's equal to the square root of negative 1 times, you got to factor this 45, all right? And it factors to the square root of 9 times the square root of 5. And now you can simplify. So square root of negative 1 is I. Square root of 9, that's equal to 3. And the square root of 5 is in simplest form. So this simplifies to, or we put it back together now in order. So we go 3i radical 5. Number 10 and 11, you're going to be graphing. Number 10, we're going to graph, let's see, negative 4 minus 4i. So we go horizontal axis is your real axis. Vertical axis is your imaginary axis. We're going to negative 4 on the real axis, so negative 4. And we need negative 4i on the imaginary. So negative 4i, that point would be right here. All right, and if you were asked to find the absolute value of it, the absolute value of negative 4 minus 4i, remember that's the distance from the origin to the point, which is the same distance as the hypotenuse of a right triangle formed here, where the horizontal section of the right triangle would be 4, and the vertical section would be 4 as well. So it would be the square root of 4 squared plus 4 squared. And that would be equal to the square root of 32, which is equal to the square root of 16 times the square root of 2, which is equal to 4 radical 2. Decimal version of that would be 4 times 2 square root, which is 5.66. I don't know if anybody remembers from geometry last year, but a right triangle with 2 congruent sides has 2 congruent angles, which makes it a special right triangle. It makes it a 45, 45, 90. And the shortcut is to multiply one of the legs times the square root of 2, and it'll give you the hypotenuse. And there it is right there, 4 radical 2. Number 11, you graph it the same way. All right. You got negative 3 minus 4i. Here's your real, your imaginary, negative 3, negative 4i. Here's your point. That's your negative 3 minus 4i. You'll just have to match it to a graph tomorrow. All right, and then we got 12, 13, and 14. So 12, 13, and 14, you're finding what is the absolute value of each number. So here we got 4 plus I. You need to find the absolute value of it. That's going to be equal to 4 squared plus 1 squared. All right? Just like up here, look, we did this value squared plus this value squared. Positive or negativeness of it doesn't matter, because when you square it, it's going to turn positive. This right here, this next problem, number 11, if we wanted to find the absolute value of negative 3 minus 4i, Well, that would be equal to the square root of 3 squared plus 4 squared. Just remember that when this I is sitting by itself, it's just like any variable. There's a 1 in front of it, but it's not written. It's implied. So you've got the square root of 4 squared plus the 1 squared. So that's the square root of 16 plus 1, which is equal to the square root of 17. And as a decimal, I'm sure you can type it into your calculator, 4.12. Number 13, you got negative 1 plus 5i. You have to find the absolute value of it. It's equal to the square root of 1 squared plus 5 squared, which is the square root of 1 plus 25, which is the square root of 26, which is 5.1. I'll let you do 14 on your own. And then if you flip your study guide over, there's 4 more practice problems on the back. And number 15 is simplifying the expression. We got 6 plus 6i plus negative 6 minus 4i. So we combine like terms. We take this 6 plus negative 6. 6 plus negative 6, that's equal to 0. And then we take this 6i plus negative 4i. And that gives us a positive 2i. So 0 plus 2i. Or you may see it as just 2i. Doing the same thing on 16. 6 plus 5i. Okay, this is subtraction. Negative 4 plus I. So look, these two right here. This is 6 minus negative 4. 6 minus negative 4. That's 6 plus 4. That's 10. Right here, you got 5i minus I. 5i minus I is positive 4i. There you go. 10 plus 4i. All right, number 17. Got negative 3i. Oh, what do we got times negative I? So we got a negative times a negative, which is a positive, right? So look what we got here. We got 3i squared. Now, we said earlier today and earlier this week as well that the square root of negative 1 is equal to I. if the square root of -1 is equal to I, then I squared is equal to -1. So in this problem right here, we've got 3i squared. All right, -3i times -x, and negative times a negative is a positive. I times I is I squared. So 3i squared is the same as 3 times I squared, which is the same as 3 times -1, which is equal to -3. So all of this up top is equal to -3. And then number 18, we've got a 1 plus 3i times a 3 minus 3i. Now, you got a binomial times a binomial. So this would be double distributive property, or FOIL, however you learned it. So we got to take the 1 times the 3, which is 3, and the 1 times the -3i, which is -3i. And then 3i times 3, which is positive 9i. And then 3i times -3i, that's going to be -9i squared. So this -9i squared, all right, or -9i squared is the same as -9 times I squared, which is the same as -9 times -1, which is the same as -9 times -1 is positive 9. All right, so this last term over here, all of this is equal to positive 9. So when we clean this up to finish it, we got a 3 plus 9, which is 12. And -3i plus 9i, that's a positive 6i. There you are, in simplest form. All right, so short and sweet on the study guide. Hopefully it's, not hopefully, but this is an opportunity to get a really good quiz score. Didn't cover a whole lot of material because you guys were testing. Class was broken up for a couple of days. So at this time, if there's no